Good morning, everybody. It is Thursday, December 14th. I have so many midterm exams to grade. I will be grading like all day today. But first things first, we need to find our 14th piece of chocolate on this advent calendar, and then we need to do some calculus. All right, let's look through here, see if we can find the 14th compartment. There's 13, there's 15, there's 24. Where is 14? Ah, there it is, right at the bottom with the little bow. That's cute. Look at that bear. He's just chilling there behind the mistletoe. Is that a mistletoe? I don't think so. That's like a wreath. I don't even know what a mistletoe is. There's 14. So I'm going to crack into this, and I will put today's free response question on screen now for you to check out. And hey, if you haven't checked out the rest of the episodes of the Advent Calendar, there's a link to the playlist in the description. And if you haven't checked out all my other calculus videos, I don't know what you're doing. There's a link to my Calculus 1 playlist in the description. I still got a lot of work to do on that, but far more substantial is my Calculus 1 exercises playlist. Ooh, it's a rectangle. My Calculus 1 exercises playlist has over 100 fully solved calculus exercises, and it's all in order. So like it follows the standard order of topics in the calculus curriculum. It takes a lot of work to put that together. I mean, it's 120 something videos. Come on. That's great. Love these rectangles. They're a lot easier to eat than the spheres. We got a position, velocity, acceleration sort of problem to do today. Going to be fun. All right. Let's get chocolate. Let's do the calculus, I guess. This is free response question 1 from the 2011 AP Calc AB exam. This is part of the calculator section. We will have to bust out our calculator a few times for this question. Let's read it. For t between 0 and 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t equals 2 sine of e to the t over 4 plus 1. The acceleration is a of t equals half e to the t over 4 cosine e to the t over 4, and we also know that x of 0, the initial position of the particle, is 2. All right, that's a whole lot of information. Part A. Is the speed of the particle increasing or decreasing at time t equals 5.5, and give a reason for your answer. Remember that speed is the absolute value of velocity. So if the velocity is getting more extreme, either more positive or more negative, then the speed is increasing. To figure out if that's happening, we need to assess both the velocity and the acceleration. If they have the same sign, then yes, the speed is increasing. If the velocity is positive and the acceleration is positive, that would mean the particle is moving to the right, and it's doing so at a faster pace because the acceleration is positive and the velocity is positive. If the velocity is negative, that would mean the particle is moving to the left, and if the acceleration is also negative, that would mean that the particle is speeding up with that leftward motion. So, if the velocity and acceleration have the same sign, then the particle is speeding up. Now I've opened up our graphing calculator. Again, for part A, we're going to look at the velocity at the time of interest, which is 5.5, and the acceleration at 5.5. If they have the same sign, then indeed the particle is speeding up. So let's start with the velocity. Here is our velocity function, and we need to plug in 5.5. So let's type that into our calculator very carefully. It's going to be 2 times sine of e to the t over 4, but we're plugging in 5.5 for t, so 5.5 over 4, and then plus 1. We see that's about negative 0.453. Before we write that down, let's just also check the acceleration. That's right here. Okay, so we'll plug this in. We have 1/2, so 1 over 2. And maybe we'll put that in parentheses just to make sure we're being careful with the calculator. 1/2 multiplied by e to the t over 4. Again, t is 5.5, so we're plugging in 5.5. multiplied by cosine of e to the 5.5 over 4, and that's it. Press enter. Okay, so we see both the velocity, which is about negative 0.453, and the acceleration, which is about negative 1.359, both of these are negative. So indeed, at t equals 5.5, the speed of the particle is increasing. It is moving to the left because the velocity is negative, and it's doing so at a faster rate as time goes on because the acceleration is also negative. And there is our reasoning written out. Moving on to part B, find the average velocity of the particle for the time period between 0 and 6. The average value of a function is found by just integrating the function across the interval in question. So to find average velocity, we'll integrate velocity from 0 to 6, and then just divide by the interval length. So we will divide it by 6. It's kind of like adding up all the values in a data set and then dividing by the total number of values in that data set. All right, so we'll write this down. The average velocity, whoops, don't need two B's there. The average velocity is what? Well, it's 1/6, because again, we have to divide by the interval length, which is 6. 1/6 times the integral from 0 to 6 of velocity. The velocity function, of course, is given. We'll go ahead and plug this into the calculator. All right, again, we'll plug this in very carefully. We have 1 divided by 6 multiplied by, I'll press the math button to access all my functions and choose option 9, the integration function. We are integrating from 0 to 6. And now I have to put in the velocity function, which I know is 2 sine of e to the t over 4. So 2 multiplied by sine of e to the, I'm just going to use x as the variable, divided by 4, and also plus 1. And we're integrating with respect to x. Again, I'm just replacing t with x. Doesn't really matter. We did also multiply by the 1/6 at the front. We'll just press enter, and there it is. I just changed the mode of my calculator to decimals so I could get a decimal answer. Exactly how you would do that on your calculator, if it was reporting fractions, may vary. A lot of calculators will have a secondary approximately option on their enter key, so you could press second enter and you would get an approximation instead of an exact value, but it depends on your calculator. So for me, I've got this decimal approximation. It is about 1.949. That is the average velocity of the particle on the interval from 0 to 6. Again, all we did was integrate the velocity over that interval and divide by the interval length. Moving on to part C. Find the total distance traveled by the particle from time t equals 0 to t equals 6. This is pretty similar to the previous problem. We will again need an integral that we will use our calculator for in order to calculate distance. Now, how do you calculate the distance traveled when you have the functions that we've got in this situation? Well, you don't want to integrate velocity because some velocities may be positive, some may be negative, and that could cancel some of the distance out. Remember, we are trying to calculate distance, so we don't care if the particle goes 100 feet one way and then 100 feet back and its displacement would be 0. We would want to count that distance as 200. Now, in order to represent that in an integral, we actually have to integrate the speed, which has no regard for sign because it's the absolute value of the velocity function. So what is the distance? Well, we have to integrate from 0 to 6 again, the speed, and the speed, like I said, is the absolute value of the velocity. Of course, having a calculator for this makes it a breeze. So coming back to the calculator, I'll press the math button to access my functions and press number 9, the integration function. Again, we're integrating from 0 to 6, and what we're integrating is the absolute value. So I will press math and then go to the num tab and then press the absolute value function. This is the absolute value of velocity. So now I have to type in the velocity function, which is 2 sine of e to the t, we're just going to replace t with x, divided by 4, and then plus 1. I have to correct this. I accidentally put times 4. This is divided by 4. And then plus 1 outside of the sine function, but still in the absolute value bars. And we're integrating this with respect to x. So this is the integral of the speed, which is the absolute value of velocity, from 0 to 6. We see it's about 12.57. So there we go. The distance traveled over this interval is about 12.573. We don't integrate velocity because some of the velocities could cancel each other out since they could be positive or negative. We just want to count all the distance traveled, no matter the direction, so we integrate speed. All right, moving on to part D. For t between 0 and 6, the particle changes direction exactly once. We need to find the position of the particle at that time. All right, there are a couple steps to this problem. If we want to find the position of the particle at the time when it changes direction, we first need to figure out when it changes direction. Now, a change in direction will be marked by a change in the sign of velocity. If we go from positive to negative velocity, or vice versa, that means that the direction has changed from right to left or from left to right. So let's open up our graphing calculator and see where the velocity on this interval from 0 to 6 passes 0, where the velocity changes sign. Going back to my calculator, I'll press y equals so I can enter in the velocity function and then look at its graph. The velocity function is 2 sine of e to the x divided by 4 and plus 1. Now I can press the graph button to get a look at the graph, and we want to look at the interval between 0 and 6 and see where this velocity function passes 0 and changes sign. And we see it appears to be right there. The velocity goes from positive to negative at t equals 5.158. It also passes 0 and changes sign to the right over here around 7, but that's outside of the interval we're interested in. So where does it hit 0? Well, in the interval of interest that we have, the velocity hits 0 at about 5.1955. And with that information, we can find the position of the particle at the time when it changes direction. It changes direction at t equals 5.1955. So what is the position at that time? Well, it's going to be the initial position plus the accumulation or integral of the velocities from 0 to the time in question. This is like taking that starting position, which we know, that's why we're starting there, and then adding up all the change from that position we know, from t equals 0 to the time we want, t equals 5.1955. Now, of course, the position at time equals 0 is 2, so this is 2, x of 0 is 2, plus this integral of velocity from 0 to 5.1955. When it comes to finding position, we do want to integrate velocity because whether the velocity is positive or negative is very important to the position. And this final thing, of course, we will deal with on our calculator. We need 2 plus the integral, so I'll press the math button and then function 9, the integration function, the integral from 0 to 5.1955, that time at which the particle changes direction, and then we're integrating the velocity function, which we've entered a million times by now. It's 2 sine of e to the x divided by 4 plus 1 outside of the sine function, and we're integrating with respect to x. Press enter. Thankfully, we're in decimal mode, so we get our decimal approximation. This is about 14.135. So at the time when the particle changes direction, which is at t equals 5.1955, the position of the particle is about 14.135. We're able to figure out quite a bit of information, even though we don't know the position function explicitly. And that completes our solution to free response question 1 from the 2011 AP Calc AB exam. Let me know in the comments if you have any questions, and be sure to check out the AP Calculus Free Response Question Advent Calendar playlist to watch all of the other episodes. There's a link in the description. And hey, if you find these videos helpful, please consider supporting Wrath of Math as a channel member for access to exclusive videos, including exclusive calculus content and all sorts of other stuff. I'll see you tomorrow for the next episode of our Advent Calendar. Thanks for watching.